Okay, we're on lesson 8.4, talking about lengths of curve, which is also called arc length, and the surface area of a volume that we have revolved around an axis. Now, the good news is that the surface area that we're looking at is usually around the x or the y-axis, so it's not like the volume that we've been doing for washer or shells where your axis of revolution is going to move around to another line. So it's a little bit quicker, all right? So the definition of an arc length, the formula for the arc length is the integral of square root of 1 plus the derivative squared, right? So depending on what variable you're deriving it with, if it is dx, then you're looking at your domain, you're looking at x values. If it's dy, you're looking on y values, right? So, and these should be parentheses like so. Oh, these are points. Okay. All right. So for number one, it says set up an integral for the length of the curve. Number two, part B, graph the curve to see what it looks like. And part C says use your graphing calculator, the FNINT, which is what we've been using for our integrals on the TI calculators to find the integral solution. So we can use our calculator for this part, or some of it, all right? So part B is already done in number one. Part B says to graph the function, and it's already done. X equals square root of 1 minus y squared is a sideways semicircle, and we only want this piece right here, this blackened piece. So that's the arc length we're looking at, okay? All right, so it says set up the integral for the length of the curve. So the trick the way to approach this is to take the derivative of my function and then go ahead and plug it into this formula. So your dx dy is equal to 1/2 1 minus y squared to negative 1/2 times negative 2y, right? So clean up a bit. You have negative y over root 1 minus y squared as my derivative. Okay, for arc length, the length is equal to negative 1/2 to 1/2 of square root 1 plus my derivative, so negative y over root 1 minus y squared, the whole thing squared, dy. Okay, I would recommend to clean this up a bit before you plug in the calculator because there's just too many too many parentheses, too many square roots, and it's easy to make a mistake. If you clean up a bit with algebra, it should be a little bit cleaner. Also, if you take a look at this arc length here, it is symmetrical, so you actually don't have to do it the entire way. You could simplify this and say, hey, I'm going to double this from 0 to 1/2. So that is another option too. Okay, you have 1 plus y squared over 1 minus y squared dy. And then I think for me, I'm just going to clean this up a little bit more by doing crisscross applesauce, combining my fractions here. So I have 1 minus y squared plus y squared all over 1 minus y squared dy. So my integral is actually a lot cleaner at 1 over 1 minus y squared dy. Okay, all right. So that is part A. Part A is to set it up. We did that. Part B is to graph it. It's already done. So part C now says use function integral. So use integral notation to figure out our final answer here. So it's 2 times the integral of from 1 to 1/2 square root of 1 over 1 minus y squared. So let me find my calculator. Go math 9, and I go 0 to 1/2 of square root 1 over parentheses 1 minus y squared, x squared, doesn't matter. As long as you're using consistent variables in your dx over here, you're okay, right? So press enter. Don't forget we got to double that. So my answer is 1.047. Remember to round it 3 decimal places for the AP exam. Okay, so length is about 1.407? Oh, 047. Okay. Ones that we present to you in the homework and on our quizzes and tests are doable without a calculator. So it is possible to do these without a calculator, and this is one of those examples. So we're doing another dy problem, I guess, because we're so often doing dx, we're so comfortable doing dx problems. So in our examples here, it's just kind of nice to change it up and do some dy problems, okay? All right, so here's my curve, and I'm trying to find arc length from y equals 1 to y equals 2. So first thing I'm going to do is, of course, find the derivative. So the derivative is going to be y to the 4th times 1/4. So y cubed, and then this is 1/8, y to -2, so -2, y to -3, right? So y cubed minus 1/4y cubed. Okay, cleaning up a bit. Because I'm going to square this, I would recommend to go ahead and make it into one fraction right now. So if you do your crisscross applesauce, you get 4y to the 6 minus 1 all over 4y cubed. Okay, now go ahead and find my arc length. Length of the curve is 1 to 2. Square root of 1 plus the derivative squared dy. All right, the derivative is 4y to the 6 minus 1 all over 4y cubed. Okay, now this is a lot of algebra. We're gonna clean this up because this one, we don't want to use a calculator. We're gonna do this by hand. Okay, so integral 1 to 2, 1 plus, I'm going to go ahead and square the whole thing out. So I get 16y to the 12 minus 8y to the 6 plus 1 all over 16y to the 6. Okay, and then combine the 1 next door, make it common denominator. So you get 16y to 6 plus 16y to 12 minus 8y to 6 plus 1 all over 16y to 6. Okay, combine like terms. There's only 2 terms that will combine. The y to the 6. So you get 16y to 12 plus 8y to 6 plus 1 all over 16y to the 6. Now, hopefully you recognize that, hey, this new fraction, this new term up here, this numerator, is very similar to my old one, except there's a minus, there's a plus instead of a minus, which means then it should factor very nicely into 4y to the 6 plus 1 instead of a minus 1, because that's how I got the minus 8 in the first step. And then so we're going backwards, we're going to backtrack. So this is going to look like 1 to 2. 4y to 6 plus 1, and the bottom is 4y cubed, the whole thing squared, and that's the square root. So that will clean up really nicely to be 4y to the 6 plus 1 all over 4y cubed. And now you can actually split this into 2 fractions, and it's a lot more doable. You will get y cubed plus 1/4 y to -3 dy. And now I can take the antiderivative. I get y to the 4th over 4 plus 1/4 y to -2 over -2 evaluated 1 to 2. Okay, so I'm going to clean up before I start plugging things in. So 1/4 y to the 4th minus 1/8 y squared 1 to 2. Okay, I'm going to plug in the 2. So 1/4, 2 to the 4th is 16, minus 1 over 8 times 4 is 32, minus 1/4 times 1 is 1/4, minus 1/8 times 1 is 1/8. Okay, so I get 4 minus 1 over 32 minus 1/4 plus 1/8. So a good thing is you can see your common denominator is 32, so it's actually a lot easier to work with on this one. So the first one, the 4 itself would turn into 128 minus 1 minus 4 times 8 is 32 plus 4 all over 32. So that would give me 128 minus 8 is 120, 120 minus 1 is 119, plus 4 is 123 over 32. And that's the length of that curve. Okay. All right. Lastly, this is surface area. So surface area is just a little bit more to the formula. You need to take 2 pi times your original function and multiply by the arc length, which we just did. So that's why these two are kind of in the same topic area, right? Okay, so the graph of the equation from A to B is revolve the x-axis, find the area or the surface area. That's what it's looking for. Oh, area of the resulting surface area. Y equals x cubed. All right, this one's a little bit nicer. We have y equals x cubed. So my dy dx equals 3x squared. Okay, we're looking at a dx problem now. Okay, which means that we're only using my x values here. Okay, all right. So surface area equals 2 pi times the original formula, so times x cubed, right? And then the arc length formula, 1 plus the derivative 3x squared And then this is going from 1. Oops, sorry. Going from 1 to 2. Okay, so this is our setup. As always, my 2 pi can go outside because it's a coefficient, right? You have 1 to 2. You still have your x cubed in here. You have 1 plus 9x to the 4th dx. Okay, so recognize that, hey, the inside has 9x to the 4th, the outside has x cubed, which means this is a u sub problem, right? So u equals 1 plus 9x to the 4th. du is 36 x cubed dx. I'm going to move the coefficient over. I'm also going to change my interval. So u of 2 is 1 plus 9 times to the 4th 16. So 145. U to the 1 is 1 plus 9, which gives me 10. Okay, all right. So now my equation, my integral now becomes, okay, my interval becomes 10 to 145 square root. So I have square root of 1 plus 9 to the 4th. So that's u to the 1/2 power. And then my x cubed dx gets replaced by 1 over 36 du. Okay, looking a little bit better. All right, so now if I clean this up, I get pi over 18. U to the 3 over 2 times 2/3 divided 10 to 145. So I'm going to clean this up. This is 9. I get pi over 27. And then plug in 145, 3 over 2, minus 10 to 3 over 2. And that's it. You leave your answer like that. If there's no calculator, you leave your answer like so. This is as clean as it can be. If it's a calculator part, then of course you plug it in and get your final answer. Okay? All right, guys, that's it.